Hello. So I also just want to say I've worked with a lot of conference organizers before. This was unprompted. So I work with a lot of conference organizers. I travel a lot, and I can confirm that Natasha Tash does a really good job and took care of me, and despite crazy Chicago fires leading to insanity. I don't know if people know this, but there was a fire in, someone set fire to the airport in Chicago, and that meant that basically any flight going into Chicago was canceled, which meant many, many ripple effects across the entire US. So I was supposed to be here 2 days ago in the morning, and I ended up being here yesterday morning, just because they had to cancel my flight for an entire day. So anyway, despite crazy things like that, I actually really enjoyed working with Natasha. So good work and good luck on your next endeavor. So what I'm here to talk about today is the future of web apps, which I think is also what you're here to learn about. So that seems good. It's a good fit. Like he said, my name's Yehuda Katz. I work on a lot of stuff, probably too many things. I'm actually here in town. In addition to being here for the Future Web Apps Conference, I'm also here for the W3C Technical Architecture Group, which is an elected body within the W3C. So that involves talking about also the future of the web, future of web apps, and what's coming down the pike. So I'm pretty knowledgeable in this area, although something that you might learn if you talk to people who are knowledgeable in this area and don't actually do practitioning work, which I do among other things, is that sometimes you can get really, really caught up in sort of what people are planning to do and not really have a good sense of how it affects real world practitioners. And so even though I do a lot of standards work, my day-to-day work and my day job for the past 10 years or so has been programming. And a thing that I've learned is that you do your best work when you're building abstractions if you're also using those same abstractions. So I'm pretty happy about that, and that's not something I don't plan on changing. And I would also recommend if anybody is interested in getting involved in working on an abstraction, be it an open source library or standards, that you don't think that just because you're a lowly practitioner that you don't have a lot to add. You might find that the people who are doing the work aren't that much in touch with what you do every day, and you might bring a lot of value. So definitely suggest getting involved in things that you use every day and maybe think are out of touch. So first of all, spoiler alert for the rest of this talk. The theme of this talk is that the future of web apps is actually in our hands. And I'm not just saying that. That's not just a theme that I say to make everyone happy. I'm not a motivational speaker. Not that good. But I really, truly think that the thing that's great about the web and the thing that's great about web apps is the amount of power that we as users of the platform have. I think that's quite different from how Android or iOS works, which is basically if you're an Apple developer, you go to WWDC or watch it streaming, and you wait with great anticipation about what stone tablets are going to come down from on high to give you a new feature that you really want. And maybe you feel like that about the web to some degree, but I think you have to really appreciate the amount of features and libraries and just general tools that you have to work with that are actually built by regular everyday developers. And that includes things that are even as complicated as like building a compiler that compiles a future version of the language into the current version. There are things like generators that can be compiled, right? So these are very complicated pieces of machinery that are all built not by some magic power, but by people who are actually doing work. So I think fundamentally that is what the future of web apps is about. The rest of this talk is about how maybe that wasn't always the case, and in what ways that's getting better, in what ways the partnership between developers and the standards bodies and the people making browsers has gotten stronger, and how maybe we should think about that. So before I start talking about the future, I think it's important to talk about the past. So how have we gotten where we are today? And I actually only started making web stuff in like 2004. So when I started, I actually got really lucky and also really unlucky. I got lucky in the sense that some of the worst parts of the platform had been over. When I started writing web stuff, you didn't have to worry about Netscape Navigator 4 anymore. And that was actually kind of a big deal. So even though IE6 is kind of stable, I sort of started when IE6 had become stable. And as horrifying as that sounds like in 2014, in 2004 that was actually a pretty good thing. But basically we started out and we had this situation where there was really only one browser. It had over 95% market share. Firefox existed, but it was in the middle of a huge rewrite, and people weren't really sure if it was going to succeed, and it had a lot of hard work ahead of it. And we sort of had the situation where practitioners were all we had, right? The people in this room were basically all the platform had because there was nobody that was actually doing anything. Internet Explorer had no team, and Firefox was really, really engaged in a catch-up exercise, which meant that anything that didn't already work was something that we would have to work on. And the standards bodies were working on XHTML, which ended up being aborted for good reason, right? So the whole standards effort, which today you maybe know and love or don't love, but you see is actually producing actual features of value. At that time, it was producing features of no value. And the WhatWG actually was doing good work at the time. I call the WhatWG's work at the time Archaeology, and I think that's still the area where they do their best work. And this is the idea that the platform is doing something, the web browser is doing something, but it's not really written down. Or if it's written down very broadly. So why don't we go in and figure out what exactly the browser is doing, write it down very clearly, so that if somebody else wants to do it, they do exactly the same thing and not some other thing. And the thing to realize is that in 2004, 2005, 6, 7, maybe even 2008, most of the time people were building stuff by looking at IE as a reference implementation and trying to figure out what's going on. So the WhatWG did really, really good work in trying to figure out a way to write down, for example, the HTML5 parser, right? Here is exactly what the parser is doing. So today, in general, if you use a browser that's not IE 6, 7, or 8, you tend to have an HTML, you write HTML and you get back the same DOM. That was not always the case. Probably many people remember that. So we kind of had the situation where the platform, good work was being done on catch up by Firefox. The WhatWG was figuring out sort of what was going on, but didn't really have enough leverage to get any new features added. IE didn't really have a team. So we had the situation where the browsers weren't really advancing. But we did have one weird trick. And the one weird trick that we had was JavaScript is Turing complete. And what it means, what that means is that even though a lot of people with a lot of extensible power or at least implementation skills, even though they weren't doing a lot of work to advance the state of the art, we had been gifted to us, thankfully, IE6 and not IE4 or IE3, with a somewhat stable DOM and a somewhat plausible implementation of ECMAScript edition 3. And Firefox, when it moved on, adopted the somewhat stable DOM and the somewhat legitimate version of ECMAScript edition 3 plus some additions that they worked on. And so what that meant is that there was a stable base there was a stable platform for us web developers to work on. Now, a lot of what that meant at the time was we have this browser and we would like to add features to it, but those features are completely unexposed. So if we want to add a little thing, we're going to have to reverse engineer the entire thing. Right? We're going to have to reverse engineer the whole thing. And an example of that would be selector engines. Right? So at the time, there was a set of selectors, which was basically CSS2, if you were lucky, maybe CSS1. So there was a set of selectors that existed. I remember when I started, there was no child selector. There was only descendant selector. That's all you had. And people wanted to use selectors for other things. They wanted to use selectors for finding elements in JavaScript. And there was no real hooks to extend JavaScript. What you had to do was you had to reverse engineer the UFO. You had to figure out what is going on here. And just for a taste of this, let's look. So Sizzle.js is kind of the end of the line there. It's a selector engine that most people use these days. It's in jQuery. But here's some examples. So just random stuff like verify that getAttribute really returns attributes and not properties, right? Prevent attribute interpolation. Use default value in place of getAttribute value, et cetera, right? And just for fun, check parent node to catch when BlackBerry 4.6 returns nodes that are no longer in the document, right? So there's all this stuff that had to be done just to reverse engineer what was actually happening, because if you wanted to add a little thing, if you wanted to add child, so the platform, the base platform was descendant selectors only. If you wanted to add child selectors, you had to reverse engineer the universe. Another good example of this is form serialization. So at the time, the platform had a capability which was when you submit a form, it will serialize it for you and send it to the server. And this was the spec, HTML4. And if you looked at what the spec said, it basically broke up the process into 4 steps. Step 1, identify what so-called successful controls, which basically mean things that are not disabled, and there's some other stuff for image buttons and things like that. Step 2, build the form data set. Step 3, encode the form data set. And step 4, submit the encoded form data set. Those are the steps. But those steps are just in the spec. They're not exposed, which means that if you wanted to extend that, if you wanted to allow someone to submit it, for example, via AJAX instead of by submitting the form, you had to go and rewrite that entire set of stuff to make it work. And the good news is that people did that, right? jQuery has a thing called $.serialize that you can use that will do the work for you, and that's great. But what it means in practice is that you have to rebuild the entire stack. You have to reverse engineer everything in order to add little features. So there's sort of good news and bad news here, right? There's things like animations, which just didn't exist and required rebuilding a large amount of infrastructure. Things like event delegation, which maybe worked sometimes and not other times. So, for example, the focus event didn't event delegate, so jQuery had to do a bunch of work to make it work, right? So we had these pieces of functionality that people were reverse engineering. Then there were things like layout engines, right? So CSS was a layout engine, but it was very stagnated in that time period. So this was the time where a bunch of frameworks existed, and they were just basically building a better layout engine system. And I would say all this stuff actually works. This is a perfectly effective way to extend the platform, but there are some limits, right? You can do this to a certain degree, but I think anybody who was around in 2005, 6, 7, 2008 remembers that there are some problems, even though it feels really good that you're successfully extending the platform, that you're building something that people can build on. So probably the first problem that existed during this time frame, remember we're talking about maybe 2007, is speed. At the time, JavaScript was simply an extremely slow programming language. So if you built something like Dojo or Sproutcore or Cappuccino, you just weren't going to be able to get very good performance. You can get certain performance, but performance ended up dominating almost everything you ever did. You had to count how many functions you called. I remember jQuery said, when you do this operation, we have to make sure we don't call more than 100 functions. And that's something that, thankfully, we don't really have to worry about anymore. We have reasonably good implementations. But at the time, this dominated almost everything. And when you can only call 100 functions, that limits how much you can build up. Another problem is that the primitives that are available are just simply not quite right. So for example, using a string plus char@ to get at individual characters inside the string is not quite exactly the same thing as binary data. You can fake it, but there are going to be limits, and you're going to start falling down. Performance is one issue, but there's also semantic issues. Another issue is composition. If I basically override the image tag to do something different, because I have to use a humongous sledgehammer to do that, you can't do something else with the image tag, right? It's not that I can build a little piece. I can intercept a little piece, and then you can intercept a little piece. Or if I rebuild the entire scrolling system, for example, because I have a native platform that doesn't let me do native scrolling, which was a thing right when iPhone came out. If I do that, then it's hard to use CSS. You can't do other stuff with scrolling. You can't deal with the same thing. So there's some composition problems. And what ends up happening is you end up having these huge frameworks like Sproutcore or Cappuccino or Dojo that handle a lot of things because they are basically building the platform. They are basically giving you a plugin architecture that you wished you had as the platform. So that's some of the limitations. Another limitation is unexposed capabilities. And I want to be very clear about what I mean about unexposed capabilities. Here I mean capabilities that the browser itself has and is doing stuff with, but it does not expose them to you. So the browser is doing something, but you can't do it. And here are some examples. So an example would be the network stack. So in 2007, there were a few ways that you could poke at the network stack. You can make an image tag or a script tag. You can use the first version of XHR. And XHR was even pretty new at the time, right, in terms of how people understood what was going on. But obviously, under the hood, the browser has a much more robust set of things that it's able to do, but it's not exposed to you. Another example would be JavaScript had a section in it called host objects, which is basically, here's a bunch of magic that we're giving the browser. The browser can do all this stuff. The browser can implement DOM in a nice way. But if you want to build something like that, you can't. You have functions, and that's about it. Then there's things like image decoding, right? Obviously, the browser has binary data. The browser has something like a graphics context it could write onto and manipulate, but you don't have access to it. The whole graphics stack, right? What's going on the GPU or the CPU, all this stuff, you don't have access to. One example of something that I find very painful, but I think a lot of people probably didn't notice because they used abstractions, is like when you type inside of an input box, a lot of things are happening. So for example, when you hit Control-V, that is actually a paste event semantically, but in 2005, you would have to basically try to figure out what platform you were on and say, okay, well, on OS 10, it's Command V, let me detect that. That's a paste event. On this platform, it's Control V. What happens if the user right-clicks and clicks paste? I have to try to detect that, right? So there's these semantic events that exist in the native platform that you're dealing with, and in 07, 08, they were not exposed that well. Things like long-term storage, just the ability to, so the browser obviously has an HTTP cache. You don't have an HTTP cache or any kind of cache in 2007. No, the browser has the ability to do direct control over memory in case garbage collection ends up mattering. You don't have access to it. So there's all these capabilities that the browser had. And if you're very astute, you'll notice that all these things are things that are fixed now, and I'll go into that later. But these are all things that the browser had access to, but you didn't. And so the way that you dealt with this problem is you would basically figure out ways to poke at the browser in a way that you knew would cause the browser to do the right thing. But that's like killing an ant with a sledgehammer, right? That's very, very difficult to make to avoid causing all kinds of other problems in the platform. So that's unexposed capabilities. And then there's a set of device capabilities. And these are things that the device has access to. And if you were writing a native app, like an iOS app or an Android app, you would have access to. But even the browser doesn't do anything with them. And I would say that in 2007, this was a thing, but not that big of a deal. And then the iPhone came out. And there were a lot of capabilities that the iPhone had that really the web didn't have. And I think one thing that people probably, it's a lot of years on now, one thing people probably don't remember about this time period is that the iPhone really touted itself as finally bringing the web to mobile devices. So before the iPhone, yes, there was a thing called the web on mobile devices, but it was so crippled that nobody was like, can I have access to the accelerometer? Like, you would never have thought that. You were using such a crippled version of the web. But when the iPhone came out, suddenly you were using a real web browser with a real screen on a plausible computing device, and the fact that you didn't have access to all these device capabilities was a painful thing. And because of the fact that regular desktops had stabilized much earlier, a lot of the things that you might have wanted to get access to on a desktop device actually existed. So it started to become noticeable that we were lacking stuff. And of course, new things like your camera on your laptop also weren't exposed. So here's a big list of things that you might want to have access to that normally as a native device you have access to, and just didn't exist. You had no way to access them. Now, sometime during this time frame, browsers started adding features, but there was another problem, which is that browsers weren't updating that quickly. So you could never rely on any features because even if you only cared about relatively bleeding edge users, browsers took such a long time to update that you didn't really have a good sense of, okay, well, allegedly the WhatWG claims that there is a feature, but when will it actually be in any browser? And this was a big issue. And I think there's still some residual notion of this today. People still say this out loud a lot, but it's not as true anymore, thankfully. So I think you should, if you hear someone saying that, you should consider the possibility that that kind of language is mostly derived from a time period where it was very painful and people are just repeating the same words over and over again now. Like, oh, when will I be able to use that? Actually, it turns out next year, so calm down. Another problem that started to happen around the same time period, 2008, 2009, is that the browsers realized that there was a problem with not having enough accessibility in the platform, but the APIs they started to provide were not low-level enough. And some, like input type equals date or calendar or whatever it is actually a good example of standards hubris, right? Like, they gave us supposedly a native date picker, but no internationalization API. So you're like, oh, I want to show this date in German style, and there was basically no way to do it at all. So there was basically a point where people realized, well, we have a lot of catching up to do. We have a bunch of features to add, and they just built these super high-level APIs like AppCache, which is like we've now solved offline, except in one very narrow, specific way that basically brings us back to this sledgehammer. I have a sledgehammer. I can try to solve things with it. And even audio and video, which I think people are quite happy with as in terms of their existence, really don't solve a lot of use cases for audio and video. So people want to be able to do like mixing with audio, or they want to have a game with audio. Having to have a game with audio that you cause the audio to play by poking at an audio tag doesn't turn out to be a good way to do things in a nice way. Turns out to have problems. So sometime around this time period, I'm not sure exactly when it started, but I think it was well underway by 2012. And somewhere earlier than that, people started to notice that there's basically a way that we can make this better. And the way to make it better is to combine the fact that users are very good at building high-level abstractions on top of primitives if the primitives exist. So instead of not having any features, and instead of trying to go with high-level only features like the audio tag, why don't we try to expose what's happening under the hood, take these unexposed capabilities and expose them, and then basically throw the door open for the people in this room, for all of us who write code for a living, to try to figure out how to build higher level stuff on it. And so I want to go back to one example that I gave before, which is processing form data. And this was a thing that was attempted to be solved by XHR2. And so originally, there were these 4 steps that were totally unexposed. And now, today, these steps are a little bit better exposed. So for example, if you have a form, you can say, give me a form data for it. So you saw it say that it says build a form data set. There is now an object in the platform that lets you get access to that form data set. And there's a way to tell XHR to send the form data. So you take the form data that you created, and you can do things like adding files to it or other binary data, and then you can send it over the web to some place using XHR. And that's definitely an improvement over what we had before. Unfortunately, if you look at this, you can see that there are still unexposed capabilities. And if you go look at MDN, you'll discover that it says, well, there's 2 ways to do it, to upload things and to serialize your form data. The second way, using form data, is simple and fast, but it has a disadvantage that the data collected cannot be stringified. The first way is more complicated, but also lends itself to be more flexible and powerful. And I think whenever you see things like this, this is pretty good evidence that there's some underlying capability that the platform is obviously doing in real life, but is not giving you. So in my view, this is a good start. This is like the kind of thing we want to see so that people can build higher level stuff, but it's still not quite right. And one thing, some stuff you may or may not be aware of about the new XHR API, in addition to the fact that it doesn't require you to do on-ready state change anymore, which was terrible, is that there's file upload now. You can just say, like, here's a file, please upload it. You get progress events, so you can implement a progress bar in regular JavaScript. And it supports binary data, so files, images, videos, stuff like that. And it composes well with other APIs. So you can make a canvas, let someone draw on it, take the canvas data, put it into a form data, and then upload it, right? That's all stuff that if you were programming 5, 6 years ago, you might have been sad about. So that's sort of an example of how I think, the way I sort of think about this slide is you had one job, right? We have this, there's 4 steps. Your one job was to take each of these 4 steps and make a JavaScript API. You didn't need to do it like this. But I think it's certainly better than it was before. Like you can see that even doing a halfway job is still much better than doing no job, right? The next thing is I said JavaScript was very slow. And sometime around this time frame that we're talking about, JavaScript got much faster. And I think people don't recognize it. So I've been writing libraries and frameworks through this entire period. And you could palpably see when it went from being a thing that you had to really be very knowledgeable because the performance characteristics were impossible, to the point where basically anybody can spit something out over the weekend and have a plausible hope of it being usable. And this is 100x in a short period of time. And since then, we've gotten even better performance. I was looking for something that extended past 2009. I suspect it leveled off after that. But we've still gotten improvements, which is great. So this is one area where I think people don't necessarily recognize it because it feels like it's like, oh, a little bit better. It's like inches, but it really affects people's ability to do libraries and frameworks. Another thing that we got around this, I don't know actually when this exactly happened, but we got the ability to deal with low-level memory and data in a way that doesn't involve garbage collection, involves binary data, and is safe. So obviously, the platform wasn't going to give you a low-level memory management that would cause you to segfault your browser. That would be terrible. But we did get the ability to do some work with low-level data structures that could be fast. And just this alone actually had a big impact on people's ability to do things like write zip or gzip or all these kinds of algorithms for the platform. Because before, trying to do it with strings and carat was an extremely painful and slow process. And just having a low-level structure that let you work with binary data directly and manipulate it was a big deal. And once this thing landed, browsers really optimized it using JITs. So you basically got reasonably good performance just out of having a low-level data structure that was good. Another thing that happened that you probably have heard of is ASM.js. And ASM.js is a pretty amazing hack. And the basic idea behind ASM.js is it turns out that if you read the spec very carefully, there are operations in JavaScript that let you say, make this a 32-bit integer, and a bunch of other things. And so what ASM.js says is if you type exactly those operations, then and don't type any other operations than those, basically only operations that can be understood in terms of low-level things, then we will compile it ahead of time into exactly those low-level operations. And so what you get is something that's very close to native speed very close to native speed, even though it's ostensibly JavaScript, and it's also backwards compatible. So other VMs, so V8, for example, doesn't have direct support for ASM.js, but they're able to get reasonably good performance just because it's working with this the low-level data structure that I showed before, this thing, right? So under the hood, it's working with this. When you say malloc in C and you compile that to ASM.js, it's working with one of these things, right? And so ASM.js is basically taking things that already existed in other browsers and saying, if you do a particular subset of the operations, we'll make sure it's fast. And here you can see a specific example. And this is something that obviously Chrome has tuned their heuristics on. But you can see that it used to be quite slow compared to native. The little gray line is C++ native. And then you can see everybody converging after ASM.js came out on the orange line is actually Firefox with ASM.js. So this post-dates ASM.js. But you can see everybody actually converge even with JITs onto really good performance, very close to native. And this is for this is one example. And here's another example, which is even after ASM.js came out, you can see that Firefox continued to tune their ASM.js engine and got much, much better performance, especially around startup and things like that. So essentially what this means is that we've gotten to the point now where if what you're trying to do doesn't involve a device capability and you're only worried about performance, you say, I know how to write it fast in C, but I don't know how to write it fast in JavaScript. You can actually get something that's very close to native performance. And that's a huge deal. That really opens up a lot of kinds of things that don't require you to ask the browser for permission. I said before that there were these things called host objects in the platform. And those host objects allowed you to implement things in DOM that you couldn't implement in regular JavaScript. So in ES5, there was a section called host object. And it said objects applied by the host environment to complete the execution environment of ECMAScript. And if you look at ES6, it actually looks like a small tweak, exotic object that does not have the default behavior for one or more of the essential internal methods that must be supported by all objects. Sounds maybe like not that big of a deal. Except that in ES6, all those things are overridable. And you might have heard of a feature called proxies. Proxies are the way that you go ahead and override them. Proxy maybe sounds like it has a very specific use case in mind. But proxies in JavaScript ES6 allow you to basically create an object that overrides any of the internal methods that previously were reserved for magic, which means that you can actually implement something that's quite like something that was only previously available to DOM in regular JavaScript. And all these things are overridable, right? These are all internal methods that used to be only available to the host. So what this means is that the DOM isn't magic anymore. Everything that the DOM can do, you can do. Actually, with one exception, which is that document.all is both returns false, but then if you try to use it, it does things, which, yeah. But in general, I don't think anybody wants to figure out how to make that work in JavaScript. But in general, what this means is that there were things that before you would have had to beg someone to go implement for you, and now you can just implement them yourself. And I think that's sort of the message of this entire story, is that the magic, things that used to be only capabilities that the core platform could give you, only things that the browser can do for you. You have to go beg a standards guy or a Firefox guy or a Chrome guy or an IE guy. God help you, although they're better now. All that stuff is liberated. You can do a huge amount of stuff that you couldn't, that previously required browser support, you can do yourself. So there's things like graphics, right? Now we have Canvas, we have WebGL. You can actually go and do things that were previously reserved. Long-term storage, we have IndexedDB. We have files that you can write to and store permanently. Permanently, it's not quite right, but for a long time. For network, we have things like WebSockets that let you write your own protocols. And so this is all stuff that has happened recently and has really opened up the ability for people to do stuff that previously would have required the platform. Now, all that's great, but I think the sort of elephant in the room is that, number one, there's still some unexposed capabilities. And number two, there are actually low-level capabilities that you would like access to that you don't have access to. So I just said a lot of things that should make you excited. If you're a web developer, we've opened the door for a lot of new stuff. But there's still more work to be done. So I want to finish by talking about sort of what's in the pipeline and what I think is coming next. So coming now is what I'm saying. Either it's already in browsers or it's coming very soon. And one example of this is custom elements and mutation observers. And custom elements are basically a feature that lets you say, hey, browser, when you see my -foo as an element in the browser, I would like you, instead of just going in and doing whatever magic the HTML spec says to do, call my JavaScript code instead. And basically, this opens up an area that was previously reserved for spec authors, which is elements, and allows you as a web author to make your own. And this may or may not seem like that big of a deal, but I think what's especially nice about it is that it's very compositional, right? So it allows you to do things that before would have required you to be inside of a framework, and then you wouldn't necessarily, if I made a custom element and you made a custom element, it might have been tricky if you were using, maybe I was using Ember and you're using Dojo, or I'm using Ember and you're using React. Making these things work together would have been tricky. But now there's basically a hook at the level of the parser that lets you plug in without having to necessarily build additional infrastructure that may not compose. So I think that's great. And mutation observers are basically a way of getting notified whenever somebody changes something in the DOM. And this allows you to basically do like, oh, when someone changes an attribute, I would like to take that information and do something with it. Like, so if you have a fake image tag and someone changes an SRC, and the way you're implementing it is you have a canvas under the hood that you're drawing onto, you need to know that someone changed the SRC so you can go and update the canvas, initiate a network request and all that stuff, right? And mutation observers let you do that. So again, these are things that the browser would have been able to do before, but now you can do it directly. You can see what's going on. This is kind of a funny one because I think people who haven't had to deal with this problem just don't realize at all that it's a problem. But today, there is actually, before this slide, there is no actual way to say, please parse a URL for me. What you have to do is you have to make an A element, and you have to say href equals whatever, and then you use the A elements API to get information out. And if you want to change the base, so your page may have a base element set on it, or it already has a base based on the relative URL that it's on. And if you want to ask the browser, like, imagine that I was at a different page. I would like to know what this relative URL would mean. You have to basically re-implement the logic. And the URL API, which is already in Chrome and probably, I don't know about Firefox, but probably soon, if it's not there already, allows you to just do the thing that the browser's already doing, right? Which is like, make me a new URL and tell me what's inside of it. Like, what's the semantics of the browser? Make me a URL that's relative to this other URL, and let me see what the answer is, right? And these are things that seem little, but every time you have to go download another library or figure out some crazy hack to do something, it adds some cost. It adds some friction to building an ecosystem. And this is great. Stuff like this, I think, are very underappreciated, but the cumulative effect of all these things is very powerful. Another example of this is the WhatWG is working on a spec called fetch. And basically what fetch does is it just exposes, so actually, I thought I had a slide for that. What fetch does is basically there's a whole bunch of stuff in the platform that triggers network fetches. And basically, there's a large algorithm inside the spec that says, here is all the things that could happen. There's cross-origin fetches. There's interactions with content security policy. There's all this stuff. And that previously was all locked up inside of, if you're lucky, specs, but most likely implementations. And the idea behind the fetch spec was, number one, do some archaeology, write down exactly what the browsers are all doing, make sure that people converge back onto something that's equivalent across browsers. And number two, create a JavaScript API. So if you want to go and do something that is equivalent to what the image tag does, you can go ahead and do that. And one really interesting thing that is happening because of all these exposes is that, for example, until now, the image tag, for example, if you made a cross-origin request, it would be willing to make the cross-origin request and somehow magically fill in the image tag, right? But you didn't really, there was no first-class representation of the fact that there was a cross-origin request that was magically filling in the image tag that you couldn't see. And because all these things are being exposed, there's actually APIs now that are opaque or tainted objects in which you get a first-class object, but you can't look inside of it. And then over time, more and more APIs, like maybe you'll be able to say, I think you already could say, take this tainted object that I got and draw it onto a canvas. And then you can't look inside the canvas, right? So basically what this is allowing us to do is it's allowing us to take even these fairly crazy security models of the web, and it's allowing us to represent them in JavaScript. So we can't actually let you see the result of making a cross-origin request. But there's no reason we can't let you get your hands on the response in a way that doesn't let you violate the security, and then give it to some piece of magic that we already know exists, right? So we already know that there's some API inside the browser that lets you make a cross-origin request and draw something on the screen. So there's no reason why we can't have a publicly exposed API that lets you make a cross-origin request and plug it into that magic API. And I think more and more we're starting to see the ability to do this, which again makes things more compositional, more useful. And sort of a way I think of thinking about all this is archaeology, and I said that a few times. My view on it is a little bit different than maybe sometimes you hear people talking about archaeology. For me, what I mean is that the first step to doing anything interesting on the web is to figure out exactly what's already happening. And a lot of times that means getting people on the same page who are doing slightly different things. But before you can expose any JavaScript API at all, before we can expose something new to us, we actually have to figure out what is happening. And so if you look at things like the URL spec and the fetch spec, always step one is what is happening. Write down the 50-page algorithm that explains exactly what's happening, and then you can figure out how to expose it. So people like the WhatWG, and in particular Ian Hickson and Anna Van Kesteren are very, very good at this. If you look at any specs that they've written, they're always very detailed and sort of worked out what's going on. So that's sort of coming now, useful stuff. There's some stuff that's coming soon that's even more exciting along these same lines. So first of all, service worker. Raise your hand if you've heard of service worker. Awesome. Someone's doing good PR. So what's service worker? So like I said before, there's all these things that exist on the platform that trigger network requests. And those network requests happen behind the scenes, under the hood, go somewhere, and then the network request is returned and they get plugged into something, right? So they go somewhere. And the point of service worker is to say that there is a place that they go to that you can access. So if there's a network request that gets initiated, instead of it just always having to go to the network layer that's very complicated and does all kinds of stuff and maybe knows about AppCache, you can basically intercept any network request and have it do something different. And then you can return a response. And one of the things that this does is offline, right? Now you can intercept things and return a response even when the user is not online. So if a user navigates somewhere, there's now an actual place where it goes. So you can sort of think of it as a little server inside your application. But it obviously opens the door for doing any number of things. Some things that are cool about this, I think, is number one, the actual implementation of service worker is just a shared worker. So 5 years ago, there was no notion of a shared worker. So you could have maybe thought about implementing something like this, but the infrastructure wasn't really there. So the fact that there's a shared worker, there's one shared worker for all the tabs for a particular area of your app, and any network request goes to that shared worker, means that you only have to have one thing running, and every network request goes to it, and they sort of have the same logic as the browser, which is that there's a cache that you have access to and stuff like that. Like I said before, it intercepts network requests, which means it supports offline use cases, but it also obviously opens the door for a lot of other stuff. And one thing that I think is not getting enough press in general is that it exposes the cache as a first-class thing that you could work with. So you actually have the ability to work with a cross-tab shared cache that you can say, OK, I've made a network request. Here's the response. Let me put it into this cache. And then subsequent requests can work with that cache. So obviously, you can try, like IndexedDB is great. Again, we didn't have it 5 years ago. We have it now. You could, in theory, polyfill it. But obviously, the way that you decide whether something's in the cache and the fact that the cache returns responses, not just blobs, including things like headers, and maybe that you can put opaque stuff in there, right? All this stuff ends up being, it's important that it actually is exposed as a thing, as a piece of magic that now you have access to. And I think one of the things that this means that's very exciting is, how many people here have worked with AppCache? Yeah, about right. AppCache exposed an offline capability to the platform, but it exposed it in a very, very particular way. And if it didn't work for you, it basically didn't do what you wanted. And what this means is that you have essentially the thing that under the hood the browser was using to implement AppCache that you can do yourself. That doesn't mean that everyone in this room should implement their own AppCache. What it means is that some people, probably some people in this room, but also other people, will implement libraries that you can use for offline. So I would imagine that Angular and Ember and React and other frameworks will have some stuff for offline. Like, it's very difficult for Ember today to do offline support because it's very difficult to actually work with offline. It involves a lot of complexity. But if you have direct access, maybe there's just a thing you can drop in that will do the right thing for you. Right? So I expect to see large amounts of people experimenting with AppCache-like abstractions that you can use in different ways, more or less declarative, more or less imperative, more or less things that you have to work with directly. And I think that's great. And I think fundamentally that's really what I mean when I say that we have access to the platform. And what I mean when I say it's about us is I think what's good is when the platform gives us low-level features that are basically exposures of its own magic, and we can basically play with it. Because I think that gives us the ability to iterate much faster than what the platform is doing. Device capabilities are a harder problem. Device capabilities have the problem of platform vendors being afraid of security. And one thing that's cool that's happened a little bit under the hood is there's this thing called Content Security Policy, or CSP, and that lets you say things like, for this page, you cannot make any requests to any third-party domains other than these ones that I've listed. Or for this page, you can't evaluate scripts. And what this possibly allows us to do is it allows us to say, maybe a browser says, I don't want to give you access to your address book because I'm afraid you're going to run a third-party ad, and that third-party ad is just going to steal the address book. So it's not that I don't trust you, application developer. It's that I don't trust any third-party ad that might happen to run on your page that's running in the global scope. And maybe CSP lets us say, I'm willing to say that I'm not going to run any third-party code on my page, and in exchange, you can give me access to more privacy-sensitive information. Maybe I will only run my app on HTTPS, right? So I think there's a way forward with device capabilities that sort of breaks the security logjam, where we say, maybe by letting people opt out of some really dangerous capabilities, you can get access to other capabilities. And I think one thing that people haven't been talking about, but I think probably people will start talking about, is right now, so the audio tag exists, and there's a thing called web audio that lets you do lower level stuff. The video tag exists, but there's no web video. And I think probably makes sense for people to think about that. So that's coming soon. And then there's the vanguard, which is what's the next set of things that I think we should be working on or thinking about. And a high-level way I like to think about the problem of what's really next is, what is an iframe? And there's some stuff that's been proposed, like JavaScript realms, the ability to say, make me a new JavaScript global scope that has some permissions, that has access to X but not Y, right? Right now, you can't make right now, if you want to make your own JavaScript global scope, you have to make an iframe. But obviously, the JavaScript global scope is smaller than the iframe. So we would like to expose that. Then there's things like it has its own scope for style. How does that work? Maybe Shadow DOM figures into that. Obviously, it has its own fetching mechanism that's not the same as the parent. Maybe a service worker fits in there. How do things get rendered? We don't really know. How does the event loop work? You're obviously post messaging to something. What is that? Is there a first-class reflection of that we can make? Et cetera, right? So there's basically all these things that happen when you say iframe src equals whatever. How does that work? How do we expose more of it so that people can do things that are iframe-like, but not exactly what the browser has already given us? And the more we can break down these big, clunky things into little pieces, the more innovation that we'll have. So in general, the idea is liberate as much of the magic as possible. Like I said, another area of the vanguard, which I think people have been super afraid of, is how does rendering work, period? Today, it works by throwing CSS at the wall and then just hoping that something squeezes out the other end, right? But clearly, there is a rendering system that exists in the browser. And exposing that is really dangerous because it's super optimized, and if you let people run synchronous code in hot paths, who knows what's going to happen. But I don't think we can get away with not exposing some better rendering model to the platform than we have now. And how does CSS work, right? There's some mechanism by which CSS causes things to happen on the page. One example of this that may or may not be what ends up getting exposed is if you read the CSS spec, there's sort of implicitly this concept of a box tree, which is there's the DOM tree and then there's a box tree, and the box tree is what's actually getting drawn. Maybe it makes sense to expose the box tree as a thing you can just write to yourself without having to go through HTML and CSS. So what does all the things that I talked about today have in common? There's this thing called the Extensible Web Manifesto, which I authored and got a lot of people to sign. And the Extensible Web Manifesto is an attempt to change how standards are written. So instead of them being a huge, big upfront design, clunky thing, then give it to web authors, have them try to use it, discover bugs, and then go through a huge process that has to be backwards compatible. What if the idea is that we expose lower level primitives that are less risky in terms of design space, and we let web authors, web developers, go ahead and build higher level stuff on top of it? Once something's on GitHub, if it's not actually in the platform, people could submit pull requests, right? What if AppCache was on GitHub? Probably would not have sucked for as long, right? And the problem is that you can't put it on GitHub because once it's on the web, you can't break the web, right? So if we expose something low level and people can experiment with higher level stuff in libraries, then people can iterate fast. If something changes and you don't like it, you can use an older version of the library, right? But we can get to a stable point that's nice, and then eventually we can say, well, it sucks that everyone has to download 50K of JavaScript for this feature. Let's put it in the platform. Once everyone's converged on a fixed point. I think everybody knows that we converge on a fixed point, right? That's basically how things end up working. So I think we should let that happen. And I think in general, we're not only the future, we're the past of the framework, and I think we should just keep doing what works. I think fundamentally the advantage that the web has over native, people complain a lot or cry a lot or are scared a lot about native. The biggest advantage that the web has over native is all of us who are willing to do stuff outside of the core of some big room somewhere, outside of someone bringing some stone tablets down from the mountain, right? We have a humongous open source ecosystem, a tremendous amount of experimentation, actually a reasonable amount of flexibility now in terms of what we can do. And I think what we really need to keep doing, I'm not just evangelizing, I think this is what's happening. What we need to keep doing is having the platform figure out what people are trying to do, and then give them not the high-level thing they're trying to do, but low-level tools that they can use to implement it. Because frankly, the platform never gets it right the first time, ever. So low-level is easier. It's easier to expose. So I think fundamentally the future of web apps is a partnership between browser vendors and web developers, right? Browser vendors are really good at, web developers are bad at security, thinking through security implications. Web developers are pretty bad at making requests that are going to be efficient. Not everybody, but a lot of people. But browser vendors are actually pretty bad at building high-level APIs. And I think there's a partnership here where we say we're trying to do this. We need hooks into the Selector engine, right? We would like a way to store things locally. And on the first attempt, right, the first attempt when we said we would like to store things locally was, here, I'll give you 2.5 megabytes of synchronous local storage. Right? That was terrible. IndexedDB is much more complicated, but you can actually paper over it, right? And I think that's better. So the future of web apps is us getting things at a low level and us building stuff on top. And I think what's exciting about that is that it means that we can't look at HTML5 or CSS3 or 4, whatever it is now, and say the future of web apps is this feature. It's not the main tag. It's not nav, right? It's a bunch of stuff that we don't know yet, because it iterates fast and it gets experimented on by people, and it's really a bunch of low-level stuff that if you look at the service worker spec, you can't actually figure out what that means for the future of web apps. And I think that's great. I think that means that we're in a very healthy place, and I think we're in a very competitive place relative to native, and I think it's something that we should all keep doing, keep evangelizing, and keep asking for. So thank you very much.